The examples that we discussed in the previous video, we were simply creating a function pointer and we were calling the function using function pointer. Let's now understand the real use of function pointers with this example. So here I have written two functions, add and multiply. Add function simply returns the addition of two numbers. Multiply simply returns the multiplication of two numbers. Then I have written a third function that takes two numbers x and y, and it takes the functionality as an input, right? It takes the function pointer as input and then it calls that function for these two numbers. So if user provides add, then this function compute is going to do the addition. If user provides multiply, then this function is going to multiply the two provided numbers. So this is an example where we are providing functionality as input. So we have same parameters and same syntax in both the functions. This is to be same, right? Because your function declaration of compute says that you need to pass a function pointer that receives two integers and returns an integer. So both the functions should follow the syntax. Then only we can pass these functions as a parameter to this function. So we have a function compute that takes two numbers x and y, then takes a function pointer to a function that receives two integers and returns an integer. And these two functions qualify this criteria. So in the main function, we are passing first two numbers 10 and 20 and passing add, right? Add is address of the add, right? When you write the function name, it's address of this add function which is received in this function pointer. Multiply is address of the multiply function. So what happens inside this function compute, we are simply calling this funptr, right, which is function pointer, and we are providing x and y as arguments. So when you pass add, the add function is called, you get the value 30. 30 is returned by this function and 30 is printed here. When you pass multiply, then 200 is returned by this function and you have 200 printed on the screen. Let's now see a real world application of function pointers. So there is a standard sort function in C++ STL that takes the address of first element of an array and address of the element beyond the last element, right, after 9, right? That's why we pass ARR plus on. So basically the sort function takes two iterators. Iterator is a concept that we have in containers in C++ STL, and when you have an array, you can pass array addresses in place of iterators because iterators are also addresses. So we pass ARN and ARR plus n, and this sort function sorts the array, right? So what we get after we sort the array, we get -9, -1, 2, 4, 8. Now if we want to sort this array according to some other criteria, by default it has sorted in increasing order. Say I want to sort the array according to absolute values. So the sort function allows you to pass a third parameter, and in the third parameter you can pass a function pointer, you can pass a lambda expression or other types. This third parameter is mainly a function object introduced in C++ 11 version, but the point is we can pass a function pointer for third parameter. And when you pass a function pointer to the third parameter, the sorting happens according to the comparison function that you provide. So the third parameter is mainly a comparison function that takes two objects. In this example, you are going to pass two integer values, and this comparison function returns true or false values to decide the order. So here is our modified program. I have written a compare function that takes two integer values x and y and returns a boolean value. So it's going to return true if absolute value of x is smaller than absolute value of y, otherwise it's going to return false. So if this condition is true for two numbers, then the swapping or rearrangement is not going to happen, otherwise the rearrangement is going to happen. So this comparison function is going to be used inside this sort function whenever it's comparing two elements. So when you write a sorting algorithm, you need to compare two elements if you're writing a comparison based sorting algorithm. So instead of doing the normal smaller than or equal to comparison or smaller comparison, this sort function is now going to call this compare function to decide whether this element is smaller or greater. And this compare function simply compares according to absolute value. So the point is, you did not have to write another sort function, right? You did not have to write your own sort function if you wanted to sort according to absolute value. You just provided the functionality of comparison of two elements of the array, and this sort function uses this functionality to sort the array for you. That's the whole point of function pointers. So we provided the pointer to this compare function, right? Address of this compare function, and sort function is internally going to use this compare function to compare the elements. Now, once this sort function has sorted the array, what are we getting? We are getting the elements sorted according to absolute value. -1 comes first, then 2, then 4, then 8, then -9 at the end.